Let's get started with today's class. In today's class, we are going to learn very important topic, which is nothing but trigonometric ratios. To understand that, we will once again be dealing with only the triangles. So first, like the trigonometric ratios. What is a trigonometric ratio? A trigonometric ratio is a ratio of two sides in a right triangle. Okay, we are as of now just restricting our trigonometric ratios only to the right triangle. Okay, it's a ratio of two sides of a right triangle. We can use these ratios to find the length of the missing side if we know one of the acute angles, or to find the measure of one of the acute angles if we know two of the side lengths. Okay, we, and for this unit you will need calculator. So trigonometric ratio is the ratio of two sides of a right triangle. We can use these ratios to find the length of missing side if we know one of the acute angles, or to find the measure of one of the acute angles if we know two of the side lengths. Okay. Later on, we will use trigonometric ratios that are not based on right triangles, but for right now we must have only right triangle, and we must identify which angles we are using. We will always use one of the acute angles and not the right angle. So it's supposed to be a right triangle, but to get a trigonometric ratio, we will use one of the acute angle and not the right angle. Okay, keep that in mind. And one more thing you have to keep in mind is, in this unit you will use calculator extensively, so please have your calculators ready, where you have those sine, cos, tan, tangent ratios function available on calculator. So try to have that kind of a calculator. Okay, let's see the next slide. Before we understand what are different trigonometric ratios, we need to know with the sides. So if I have a right triangle, and with respect to this particular angle, I have to name this triangle. If I have to name this particular triangle with respect to this particular angle, then the hypotenuse will remain constant. Hypotenuse is the largest side which is opposite to the right angle. Okay, the hypotenuse is the largest side opposite to the right angle. And for this particular angle, this is your adjacent side, leg adjacent to angle A, and this is the leg opposite to angle A. Naming of a right triangle is very important, so just keep this in mind. This is how we name the right triangle before we see the ratios. Side AB is the hypotenuse, side BC is the opposite side for vertex A, and side AC is the adjacent side of the vertex A. Okay, this is how you name. If you want to note down this, I'll give you like 30 seconds. Please note down how to name a right triangle. Then we will move on to the next slide. Okay, let's move on to the next slide. Okay, there are three trigonometric ratios we will use in this class, and they are sine, cosine, and tangent ratios. Okay, there are three trigonometric ratios. One of them is the sine, and second one is cosine, and the third is tangent ratios. Okay, we will see what are those ratios. Okay, if I want to find tan A, so for this example angle A is here, tan A, tangent is always going to be opposite leg over adjacent leg. You'll have to keep that in mind. How to find the ratios? You'll have to memorize these: what is tan, what is cosine, what is sine, so that you can apply it to various problems. Always tan is going to be the ratio of the opposite side over the adjacent side. So length of the leg of the opposite to angle A divided by the length of the adjacent to angle A, that is BC over AC. That's your tan A. Same way, I will write here cosine. cosine A or cos A. In short, they can say cos A or cosine A is nothing but the adjacent of length of the adjacent side by hypotenuse. Length of adjacent over hypotenuse. I want you all to note down with me. That's why I'm just trying to write by the length of the hypotenuse. Which is the side adjacent to A? This particular side is adjacent to A. Other than the hypotenuse, this is the side which is the leg adjacent to A is CA. So CA over AB. If I do that, I will get the cosine or cos A. Same way, I have side of A is opposite leg, length of the opposite leg of A divided by hypotenuse. Length of opposite leg to this particular angle A divided by hypotenuse, length of the hypotenuse, which is nothing but in this case length of the opposite leg of angle A. Opposite to angle A is this particular side which is BC, and hypotenuse is AB or BA, both are same. Okay, this is your side A. I want you to note down these three trigonometric ratios. I'm going to give you exactly minute, then we will see problems based on that. So please note down these three trigonometric ratios: cosine, sine, and tangent. They have those ratios written here, but as of just note down this figure first and try to note down the tan and also sine and cosine in same manner. I can scroll down in exactly a minute and I'll pause there also for 30 seconds. Okay, I'll scroll down for another 30 seconds for you all to note down this in case you want to note down using these. Okay, what I'll do is I will do a few problems for you. I'll do whatever is in Y. I'll do whatever is there on the left side and I want you to try whatever is there on the right side. Okay, let me label them. So call this as 1, 2, 3. And this is your 4, 5, and 6. Okay, tan Y. Okay, tan Y is nothing but I will use opposite side. I will call it as, instead of writing opposite side, I'll just call it as O. Okay, opposite leg, opposite side or opposite leg, I'll call it as O, and hypotenuse I'll call it as H. And adjacent I'll call it as A. Okay, let's do this problem. What is tan Y? In the previous slide, we saw that tan Y is nothing but opposite side divided by adjacent. Opposite side over adjacent side. Opposite leg or adjacent leg or opposite side over adjacent leg. Where is y? Y is located over here. So for y, I'll use red. For y, I'm using red on this particular triangle. The opposite side is this particular, so I'll label this xc as opposite, and this is your adjacent, and this is your hypotenuse for y. Okay, so y I'm using red color to label on this triangle. So in this case, opposite is 20 and adjacent is 15. So substitute that 20 over 15. Okay, if you want further simplify here, 5 times 4 and 5 times 3. So 4 over 3. That's your tan y, or you can further simplify and give an answer in decimal, that is 1.333. I'm just leaving it over here, 4 over 3. Same way, tan x. X is over here. Let me use different color this time. Let me use purple for the x's. X is here, and for x, the opposite side is this particular. This is your opposite. Now yz becomes the opposite. For x, yz is this is your opposite side, because for x this becomes the opposite, and this becomes the adjacent. Hypotenuse will remain the same, and this is your hypotenuse. So let me substitute here. Same formula. It is going to be opposite over adjacent. So the opposite side here is 15 and adjacent side is xz, which is 20, which is nothing but 3 over 4 if I further simplify. Okay, let me do the last one. Cos of y. Y was in red, so let me use the red. Cos of y. And what is the formula for cos? The formula for cos is nothing but adjacent over adjacent side over the hypotenuse. Okay, let's see for cos y. For y, which is the adjacent? For y was it red, and for that the adjacent side is a here right next to y, which is 15, and the hypotenuse is 25. So 15 over 25. And if I further simplify this, I'll have 5 times 3 and 5 times 5. So the ratio is 3 over 5. This is by cos y. I want you all to try 4th, 5th and 6th. I'll give you like a minute and a half. Label the answers in chat. 4th one what you have, 5th one what you have, and 6th one whatever you have. Okay, use your chat once you have the answer. Okay, let's go back to solution. What is our side y? And we were using red for y, so I'm just going to keep red itself. And side y was nothing but opposite over hypotenuse. In this case, y is here, this was your y, opposite is 20 and hypotenuse is 25. So I'll just write 20 over 25. 20 over 25. Further, if I simplify, this becomes 5 times 4 and this becomes 5 times 5. So we have 4 over 5 as the side y. Let's see the cos x. And for x, we were using purple. And that is, cos is nothing but adjacent over hypotenuse. Now for x the adjacent side, is 20 and the hypotenuse is the 25. So 20 over 25, once again we have the same answer, that is 4 over 5. I hope I'm clear. If you have any questions, please raise your hand. I will just take a look at your hands after this particular problem and help you. Side x. For side x, x is here and side is nothing but the ratio of the length of the opposite side over the length of the hypotenuse. Length of the opposite side is 15 and length of the hypotenuse is 25. So 15 over 25. I'm just writing opposite over hypotenuse. In short, instead of just writing length, opposite over hypotenuse is nothing but 15 over 25, which is nothing but 5 times 3 and 5 times 5. So we have 3 over 5. I hope this is clear. Let's see the next slide. Okay, I'll do this first part, then I give you a chance to work on the second part. Find the tangent ratio of for angle A. They are asking us to find the tangent ratio for angle A. So tangent of A is nothing but opposite over adjacent. Okay, length of the opposite over the adjacent, length of the adjacent to this particular A. So in this case, the opposite is CB and adjacent is CA. This is the hypotenuse. So we should have CB over CA. We have the value of CB, but we don't have CA. But this is a right triangle and I can simplify for CA. CA is nothing but square root of 50 square minus 14 square. So 50 square minus 14 square. Okay. Use calculator, simplify. I'll give you 30 seconds. Then we will go over the solution. Find CA. So this is from your Pythagoras theorem that AB square equals CB square plus CA square, and I've just simplified further directly. That is, I should have 50 square equals CA square plus 14 square. And simplifying further, I got this, and this is nothing but 48. Now we substitute here. CB was 14 and this was 48. Okay, further I can simplify this as 2 times 7 and this as 2 times 2 and 2 times 4, 24. And I can't simplify further, so just leave the answer here. It's 7 over 24. I just want you to try tangent ratio of angle B in same manner. Okay, tangent ratio of angle B. Use your chat. Once you have the answer, I'll give you 30 seconds. Tangent ratio of angle B. For tan B, once again it's going to be opposite. I'm writing opposite as OPP and hypotenuse just HYP. Okay, opposite over hypotenuse. For B, the opposite side is this one. So CA will be the opposite side, and for this one, the adjacent side is AB. So you will write here CA over CB, which is nothing but 48 over 14. And if I simplify that, I'll get 24 over 7. If you want, you can write later this in a mixed fraction, or even if you want, you can write in decimals. Okay, let's see the next problem. What is the relationship between these two slides ratios? what is the reciprocal of the other, right? Observe here, each of there is a relationship between tan A and tan B. The relationship between these two is the one is the reciprocal of the other, right? The ratios are reciprocal of one another if you want to write it that way. The ratios are reciprocal of one another. I hope this is clear. Okay. Let's see the next slide. What ratio could we set up using triangle below? Okay. What ratio could we set up using triangle below? I'll give you exactly 30 seconds and then we can go over the solution. What ratio could we set up using the triangle below? Take 30 seconds and try to get the answer. Okay, over here, I have this particular angle given to me. I have this particular angle. I don't have this angle, so no use of using this particular angle. But I know this particular angle and I know these two sides. For this particular angle, this is going to be the opposite and this is going to be the adjacent. I'm using OPP for opposite, ADJ for adjacent. Okay, and I know that opposite over adjacent is nothing but tan, right? Tan of what particular angle? This angle. This angle is 50 degrees. So I can write tan 50 degrees equals opposite over adjacent. In this case, the opposite is x and this is 5. Okay. Now, all of you use your calculator. Make sure it's in degrees and try to find the tan 50 degrees. I'll give you exactly like a 30 second. So it will be 1 point. Tan 50 is nothing but 1 point. I'm just rounding to third decimal place. 1.91 1.192. Okay, this 1.192. Okay, this is tan 50 degrees if you put in that in calculator. You have to use, make sure go to mode and change if it is not in this near this particular answer because it has to be degrees and not radians. And now cross multiply to get the answer for x. If there is nothing, then there is 1. So you cross multiply, you'll get 5 times of 1.192 equals x. So once again, use your calculator, multiply 1.192 with 5, which will give us 5.959. So x will be 5.959. Okay, this is how you solve these kind of problems. Okay, when there is a missing side and the angle is given, you can find out which ratio to use. Use that particular ratio and find the missing side. So in this case, 50 was given and we were given opposite and adjacent sides were involved. With regards to 50, these were opposite and adjacent, so it is tan of 50. Tan 50 is opposite over adjacent. Substitute tan 50 equals x over 5. Tan 50 using calculator you get 1.192 and further you cross multiply to get x equals 5.959. Okay, let's see some more problems. Okay, we will get across those kind of problems real quick. Let's see this particular slide. Solving problems using trigonometric ratios. Okay, the first step is identify the reference angle, determine which sides you are given opposite, adjacent and hypotenuse, and which side is a variable you are finding. Write equation using the trig ratio for the two sides. Solve the equation for variable. For example, I'll show one of them one more time. Here, identify the reference angle given. So this is my reference angle, first step, when you're solving for basic side. The second step, determine which sides are given. With regards to 36, this is my opposite side. The sides involved are opposite. And hypotenuse. Sides involved are opposite and hypotenuse. So the next is write equation using trig ratio for those two sides. Whenever we have opposite and hypotenuse, it is going to be sine. So you just write the trig ratio. Sine of 36, because that is the angle, is nothing but opposite over hypotenuse. So further substitute. Opposite was x and hypotenuse was 8. Okay, I'll just write here sine 36, and this is in degrees, okay, no, not in radians. 36 degrees equals x over 8. Once again, to get sine 36, use your calculator. Okay, sine 36 degrees. Let's use calculator and tell you sine 36 degrees. Okay, it's going to be 0.588. Okay, so sine 36 degrees, if you use calculator, it will give us 0.588. Point, let me extend the page. Round up to third decimal always if nothing is mentioned, over x over 8. Now cross multiply to find the value of x. So if I cross multiply, I'll get x equals 8 times of 0.588, which is nothing but, once again use calculator, 4.702. So I got my x as 4.702. I hope these kind of problems are clear. Let's see the next slide. Solve the missing side. Okay, what I'll do is I'll do one of them and then give you a chance to work on the other. Okay, you are doing the first and third. Go ahead and get started working on the first and third problem. I'll do the second problem for you all. Okay, work on the first and third. So second one here. First, the reference angle is this. With regards to this reference angle, have this as the adjacent and this as the opposite. And opposite and adjacent are involved, so this is going to be tan. So we have tan 44 degrees equals opposite over adjacent, which is further going to be 21 over x. And I'm going to use calculator to find tan 44 degrees. Tan of 44 degrees. is nothing but 0.966. So I get here 0.966 equals 21 over x. Okay, further cross multiply, I will get x equals x times 0.966 equals 21 dividing by 0.966. So I get x equals 21 over 0.966. Okay, let's use calculator once again. So I have 21 over 0.966 and that gives me the answer as 21.739. So x equals 21.739. Same way, all of you just work on the first and third problem. I'll give you exactly like I'll give you like a couple of minutes here. Just try to complete that. Third one, on the first one, once again, for the reference angle is 26. With regards to that, this is your opposite and this is your adjacent. Whenever the opposite and adjacent are involved, we are going to use tan. So tan of 26 is nothing but opposite over adjacent. I'm directly writing 7 over x. Okay, tan 26, use your calculator. Tan 26 degrees will give you 0.488 equals 7 over x. So further simplify this to get x equals 7 over 0.488, which we had got, but further we can simplify that using calculator. 7 over 0.488. Let's use calculator. And that gives us 14.344. Good job, Bia. All of you try the third one. I'm waiting for the third answer. Okay, try the third one. And for the third one, once again, we have this particular 73 degrees. With regards to that, 58 is going to be the opposite and x is going to be the adjacent. So we have tan 73. Tan 73 equals opposite over adjacent. I'm directly writing 58 over x. Okay, let's use calculator and find tan 73 real quick. So tan 73 degrees. Tan 73 degrees is nothing but 3.27. 3.271. So I get this as 3.271. That's 58 over x. Okay, cross multiply further, I get x equals 58 over 3.271. Emma, please check your answers once more. 3.271. So I'll get 58 over 3.271 as final answer, and that is going to be 17.731. I hope this is clear. Okay, let's see the next slide. Okay, Solve for both the basic sides they are asking. We'll get to that uh, real quick. Let's see some more problems. Uh, all the problems are similar type. Okay, where we have to find one or the other basic side. Okay, before I do those problems, let's see few special right triangles. That is side 40, 45, 30 and 60 will be our special right triangles which we will use, and we will see angle of elevation depression later. So let me first finish this part, then we will see those problems which we had left previously. Okay, sine 45, just observe here, sine 45 is nothing but I can take any 45 degrees and go by opposite over hypotenuse. Okay, so here sine 45 with regards to this is going to be x over hypotenuse, which is x root 2. Okay, you can remember that sine 45 is nothing but 1 over root 2. Okay, because we already know the special right triangle. From that, these two are special right triangle. From that we can find sine 45, sine 30, sine 60. You want to find sine 30, so go here. Sine 30 is nothing but opposite over hypotenuse, which is nothing but x over 2x. That gives us 1 over 2. Okay, in case of special right triangle, we had seen that the 45 45 90 triangle has both the legs equal and hypotenuse is x times root 2. In case of 30 60 90 triangle, we had seen the smallest side is x, the hypotenuse is 2x, and the other leg is x root 3. If you are interested in sine 60, the opposite is x root 3 and hypotenuse is 2x. So substitute here x root 3 over 2x. If I further cross out x, I get root 3 over 2. That is the value of sine 60. Okay, without calculator you can get these numbers. So if you have problems based on 30, 45 and 90, you should know how to do without calculators. Let's see further cos. Cos is what? Cos is for this 45 degrees adjacent over hypotenuse. It's going to remain the same, x over x root 2, which is 1 over root 2. Then cos of 30 for 30 degrees adjacent over hypotenuse. Cos 30 is nothing but adjacent over hypotenuse. Adjacent is x root 3, hypotenuse is 2x, which gives us root 3 over 2. Then the cos 60 for this particular angle 60, the adjacent is x and hypotenuse is 2x, x over 2x. That gives us 1 over 2. And finally we are going to the tan. Tan 45, it's nothing but opposite over adjacent. So x over x, that gives us 1. The tan 30, 30 is over here, the opposite is x, adjacent is x root 3. So x divided by x root 3, because tan is the ratio of opposite over adjacent. So that gives us 1 over root 3. Same way, tan 60 is going to be opposite over adjacent. In this case 60, the opposite side is x root 3 and adjacent is x. So x root 3 over x. So whenever you come across these special right triangles and you're not allowed to use calculator, you should know how to get these numbers using these two triangles. That's what I showed here. Okay, let's see the problems which we had left previously. Okay, and it's better for you to memorize these numbers which we saw. Okay, you got to memorize these, or you should be able to simplify real quick and get these numbers. Okay, solve for both the basic sides. What I'll do is, due to as we have shortage of time, I'll just real quick go ahead and solve the problems. Okay, I want you to try only the third one. I may not work on this one at all. I'll just try to do two in each of the slides and give you time to work asynchronously. So on this one, the angle involved is 53. With regards to that, this is your opposite, this is your hypotenuse, and this is your adjacent. Okay, firstly I'm interested in finding the adjacent. Okay, think that I'm interested in finding the adjacent. So I'll have tan 53 equals opposite over adjacent. So substitute that, opposite over adjacent. Opposite was 22, adjacent was A. And if I use calculator to find tan 53 degrees is nothing but 1.327. So I get here 1.327 equals 22 over A. So further if I simplify, I'll get A equals 22 over 1.327. 22 over 1.327. If I substitute that in calculator, I have 16.579. A as 16.579. So I get A equals 16.579. Okay. Same way, let me find the B. To find B, I will use the one which I know, one which I don't know. I have to use opposite and hypotenuse. I have to use these two sides to find B. I can't use this one, but I know now, but better to use this. Opposite and hypotenuse is nothing but your side ratio. Whenever the opposite side and hypotenuse are in what? Side ratio. So use side of 53 equals opposite over hypotenuse. Opposite side was 22 and hypotenuse was B. Once again, use your calculator to find side 53. So you have side 53 degrees. That is 0.799. So we have 0.799 equals 22 over B. And if I use calculator further, I get B equals 22 over 0.799. So if I do 22 over 0.799, that gives us B as 27.534. 27.534. So in this case, B equals 27.534. Okay. Let me do one more problem. As I said, I'll do one more. This one I'll give you to work. This one, the angle is over here. With regards to this angle, this is going to be your opposite. This is your adjacent, and this is your hypotenuse. Okay, once again, we always have to take one of the side that is given and one that is not given. So let's do opposite over hypotenuse. Opposite over hypotenuse is nothing but sine. So we have sine 36 equals opposite over hypotenuse, that is E over 2 root 7. Use calculator and find sine 36. So sine 36 degrees using calculator, I get 0.588. So I have 0.588 equals E over 2 root 7. So further cross multiply, you get the value of E. 0.588 times 2 root 7. That gives us 3.110. that is your E. Same way, I need to find the value of F also. To find F, I have to take this particular side which is unknown and this side which is known. So adjacent hypotenuse, the ratio, whenever adjacent and hypotenuse are involved, it's cos. So we'll use cos 36. So cos 36 degrees equals adjacent over hypotenuse. So adjacent side was F and the hypotenuse was 2 root 7. Once again use calculator to find the value of cos. Cos 36 degrees which is nothing but 0.809. 0.809 equals F over 2 root 7. Okay, cross multiply further to get F equals 0.809 times 2 root 7. Let's use calculator further to multiply that to 2 root 7. Which gives us 4.281. So I'll have F equals 4.281. Okay. Due to shortage of time, I'm unable to get to this particular problem, but I can give you a hint and you can further simplify this. I'll not be doing calculations on this one. You can do calculations whenever you get time. So here I have, this is the reference angle. This is your opposite. This is your hypotenuse opposite to the right angle, and this is your adjacent. Okay. Let's see first. We have to always involve the adjacent. Adjacent over hypotenuse will give us cos 31. So cos 31 equals adjacent, that is 79 over m. You can further simplify using calculator m. Same way, I have to involve, to find n, I'll have to involve opposite and adjacent. Opposite and adjacent is nothing but tan. So tan 31 equals tan 31 degrees equals opposite, that is n over 79. Okay. You can further simplify. I'm not going to go ahead and solve. This is how you will find the basic sides, and there will be worksheet where you'll be working on these kind of problems later today. Okay, let's move to the next slide. Okay, find value of x. This will be the last slide that I will work out, then I'll give you time to work asynchronously. Okay, so let's do all these three real quick. So this is the angle that is involved. With reference to this angle, this is the opposite and this is the adjacent. So we have, whenever opposite and adjacent are involved, it's going to be tan. Tan 64 equals opposite over adjacent, that is tan over x. Let's use calculator and find tan 64 degrees. So tan 64. Tan 64 degrees is 2.050. 2.050. So here I have 2.050 equals 10 over x. So further cross multiply, you will get x equals 10 over 2.050. 10 over 2.050 gives us x as 4.878. This is going to be 4.878. Okay, I hope this is clear. Same way on this one, they just want this particular value. Okay, this problem is a bit trickier, so all of you please observe. You can use either 63 or 27. Let me use this time 63. If I use 63, this is going to be the opposite and this is going to be adjacent. So I can say tan 63 equals x over 15 and solve this problem, or I can say tan 27 equals 15 over x and solve the problem. Both will give us the same answer. Okay, you can use one of them. Do not get confused when you have multiple reference angle. So you can choose any one and but name the sides according to that particular angle. So if I choose 63, this becomes the opposite, this becomes the adjacent. If I choose 27, this is opposite and this is adjacent. Okay, I could have written here tan 27 equals opposite to 27 is 15, adjacent is x, 15 over x. You could have done this way. Anyway, let's simplify this using tan 63 equals x over 15. So tan 63 degrees is nothing but 1.963. So 1.963 equals x over 15. And further multiplying, I get x equals 15 times 1.963. 15 times 1.963 gives us 29.439. So I get x equals 29.439. Okay, let me do this last one. Then I'll give you a chance to work on there are a couple of two problems. I'll just work on these two. Then I'll give you time to work asynchronously. So please observe this one. They wanted perimeter. I don't have this particular x and I don't even have this value. Let me call this as y. I will need this. They are not just asking us to find x. I'll have to find x and y. So first let's find x using one of the reference angle. With regards to this 55 degrees, this is by opposite and this is by adjacent. Okay, you can choose either 35 or 55. Any of the reference angle is fine. So tan 55 is whenever opposite and adjacent are involved, we'll use tan. Tan 55 is opposite over adjacent, which is 12 over x. Further substitute tan 55 degrees in calculator and that gives us tan 55 as 1.428. So I have 1.428 equals 12 over x. And x, if I further simplify by cross multiplying, I get x equals 12 divided by 1.428. 12 divided by 1.428. That gives us 8.403. X equals 8.403. You can once again use trig ratios and find the value of y. You can use same like opposite over hypotenuse and find the value of y, or you can use the Pythagoras theorem and find the value of y, whichever you prefer. Okay, there are several ways to find y. You can find y using trig ratios. I can call this as opposite and hypotenuse. Opposite over hypotenuse is sine 55 and find, so I'll have sine 55 equals opposite, which is 12 over y. I can find by this way, or I know this particular side now and I can use the Pythagoras theorem and find. You're already aware with how to find Pythagoras theorem. You have worked several problems, so I'll just use this method. Sine 55 equals 12 over 5. So let's see sine 55 degrees using calculator. So sine 55 degrees is nothing but 0.819. So I get 0.819 equals 12 over y, and y is 12 over 0.819, which is nothing but 14.652. And perimeter, finally the perimeter we were interested in. So the perimeter is going to be x plus y plus 12. Okay, substitute 8.403 plus 14.652 plus the 12. Okay, that gives us 35.055. 35.055. That's the perimeter. Okay, I'm just leaving it as P. At the last one, they were asking us to find the area of this particular rectangle. We need just this one. Area is what? Length times width. Area of rectangle is length times width. So I know this is 8, but I don't know this value. To find that, we'll use this as the reference angle with regards to that W is the opposite and this is the adjacent. So tan 41 equals opposite, that is W, over adjacent, that is 8. So use your calculator once again and find tan 41 degrees, which is 0.869. So I get here 0.869 equals W over 8. Okay, 0.869 equals W over 8. So further simplify using calculator, you'll have W equals 8 times of 0.869. So multiply this with 8. Multiply with this with 8 and you will have 6.954 as W. W equals 6.954. And area is length times width, which is nothing but 8 times 6.954. If you multiply by 8, you get 55.634 as the area. Area is 55.634. Okay, we will do last couple of slides in the next class, which is based on the angle of elevation depression. We will take up that in the next class. I want you to do odd problems on not this particular worksheet. I have posted a trig. Uh, do all the problems. Okay, do all problems and on the worksheet on trigonometric ratios worksheet, and also work on the debrief. Okay, you have rest of the class time to work asynchronously. Okay, if you have any questions, you may just raise your hand. I'll just help you with. Okay, do all problems on trigonometric ratio worksheet and debrief. Debrief 2A.